In late 2023, a shockwave ripped through the scientific community. Headlines exploded across the globe with a staggering claim. The James Webb Space Telescope had detected a distant planet with a 99.7% statistical probability of hosting alien life. The target, K2-18b, a massive, mysterious world orbiting a faint red dwarf star 120 light-years away. For the first time in human history, we weren't just guessing if aliens existed. We had a smoking gun hidden in the chemical barcode of a distant atmosphere. But as the data leaked out, a fierce, high-stakes battle ignited among astrophysicists. Did James Webb actually find an alien paradise, or are we looking at a deadly cosmic illusion? What scientists discovered there has sparked intense debate, global interest, and a new chapter in the search for life in the universe. And the story begins with a planet unlike anything we've ever seen before. K2-18b lies within the constellation Leo. By human standards, it is unimaginably far away. A spacecraft traveling at the speed of our fastest probes would take millions of years to reach it. But in the vast scale of the cosmos, K2-18b is relatively close. Close enough for our most powerful telescopes to study its atmosphere and reveal clues about what may be happening there. This is not a small rocky planet like Earth. K2-18b is much larger. It is about 2.5 times wider than our planet and more than 8 times heavier. Scientists place it in a category known as a super-Earth or a Mini-Neptune, worlds that are larger than Earth but smaller than the giant planets of our solar system. Its size allows it to hold onto a thick atmosphere, and as it turns out, that atmosphere may hold the key to one of the greatest discoveries in modern science. The story of K2-18b did not begin with today's powerful telescopes. It began in 2015. That year, NASA's Kepler Space Telescope detected a small drop in the brightness of a distant star. This dimming happened because a planet was passing in front of the star, blocking a tiny amount of its light. This method, known as the transit method, has helped astronomers discover thousands of planets beyond our solar system. Among them was K2-18b. At first, it was simply another entry on a growing list of distant worlds. But over the following years, scientists began to realize that this planet was special. In 2017, observations showed that K2-18b orbits within what astronomers call the habitable zone. This is the region around a star where temperatures may allow liquid water to exist. Water is one of the most important ingredients for life as we know it. Wherever water exists on Earth, life seems to find a way to survive. So finding a planet in the habitable zone immediately made scientists pay attention. Then came another discovery. In 2019, astronomers studying the planet's atmosphere found evidence of water vapor. For the first time, a potentially habitable exoplanet was known to contain water in its atmosphere. It was an important moment. But even greater discoveries were waiting. In 2021, the James Webb Space Telescope was launched into space. This remarkable observatory is the most powerful space telescope ever built. Its giant mirror and advanced instruments allow it to study distant worlds with a level of detail that was impossible only a few years ago. Among its early targets was K2-18b. As the planet passed in front of its star, Webb carefully examined the starlight filtering through the atmosphere. Every gas leaves its own signature in light. By studying these signatures, scientists can determine which chemicals are present. It's a little like reading a barcode from across the universe. And what Webb found was fascinating. The atmosphere appeared to contain methane. It also contained carbon dioxide. Both are important molecules that can tell us about a planet's environment. But there was another possible signal that attracted even more attention. Scientists reported evidence of a chemical called dimethyl sulfide, often shortened to DMS. Here on Earth, DMS is mainly produced by living organisms in the oceans. Tiny marine plankton release it into the atmosphere as part of their natural life processes. As far as we currently know, life is the primary source of this chemical on our planet. This immediately raised an intriguing possibility. Could something similar be happening on K2-18b? could living organisms be producing this gas on a world 120 light-years away? The answer is not yet known. And this is where science becomes both exciting and careful. Scientists do not simply see a molecule and declare that life exists. Instead, they examine every possible explanation. Could volcanoes produce it? Could unusual chemical reactions create it? Could there be processes we do not yet understand? These questions are essential. Science moves forward by testing ideas, not by assuming them. When you stack the evidence together, the picture looks incredibly compelling. K2-18b sits perfectly inside its star's habitable zone. Its atmosphere is choked with water vapor, methane, and carbon dioxide. And then there is that final tantalizing ingredient, dimethyl sulfide, or DMS. On Earth, this exact chemical is only produced by one thing: living, breathing, microscopic marine plankton. If you saw this exact chemical signature on an unknown planet in our own solar system, you would declare the search for alien life officially over. But searching for life across a 120 light-year void is never that simple. Unknown chemical or geological processes may still account for what we see. For now, no one can claim that life has been discovered. What scientists can say is that K2-18b has become one of the most promising places ever found in the search for life beyond Earth. To understand why, we must look deeper into what this planet may actually be. Many researchers believe K2-18b could belong to a new class of planets known as Hycean worlds. The name combines two words, hydrogen and ocean. K2-18b isn't a rocky cousin to Earth. It belongs to a radical, theoretical class of planets known as Hycean worlds. This means it's a world wrapped in a crushing, hyperdense hydrogen atmosphere, blanketing a single planet-wide global ocean. There are no continents here, no islands, no beaches, and no mountains breaking the horizon. Just a limitless, roaring alien sea spanning thousands of miles in every direction. And yet, it might still support life. In some ways, it could even provide stable conditions for extremely long periods of time. A thick atmosphere may help keep conditions stable over long periods of time, and time is one of the most important ingredients for evolution. There is another advantage. K2-18b orbits a red dwarf star. These stars burn their fuel very slowly and can survive far longer than stars like our Sun. If life began on K2-18b, it may have had an extraordinary amount of time to develop. So, what might such life look like? The truth is that nobody knows. When people imagine aliens, they often picture creatures that resemble animals or humans. But nature is rarely so predictable. If K2-18b is truly an ocean world, then life there would have followed a very different path. Perhaps it began as microscopic organisms drifting through warm waters. Perhaps it evolved into larger creatures adapted to deep oceans. Perhaps entire ecosystems exist beneath thick layers of cloud and atmosphere. On Earth, life survives in places once thought impossible, from deep ocean vents to frozen polar regions. These discoveries have taught scientists an important lesson. Life may be far more adaptable than we once believed. If the right conditions exist, biology may find a way to emerge even on worlds that look nothing like Earth. And if that is true, then the universe may be filled with possibilities we have only begun to imagine. The discovery of K2-18b is important for another reason. For decades, the search for life focused mainly on planets that looked similar to Earth. Scientists searched for rocky worlds with thin atmospheres and temperatures like our own. K2-18b challenges that idea. It suggests that entirely different kinds of planets may also be suitable for life. The universe may not need to create another Earth. It may have many different ways of creating living worlds. That realization is changing the way astronomers search the cosmos. Future telescopes are already being designed to study planets like K2-18b in even greater detail. Researchers hope to measure atmospheric gases more precisely. They hope to confirm whether DMS is truly present. And they hope to discover whether there are other chemical signatures that point toward biology. Each new observation brings us closer to understanding this distant world. For now, K2-18b remains a mystery. We have not found cities, we have not detected radio signals. We haven't photographed alien creatures swimming beneath distant waves. What we have found are clues. Clues hidden in starlight. Clues carried across 120 light-years of space. Clues that suggest that one of humanity's oldest questions may finally be within reach of an answer. Perhaps K2-18b is home to simple microscopic organisms. Perhaps it hosts ecosystems unlike anything on Earth. Or perhaps nature has another explanation waiting to be discovered. Whatever the truth may be, this distant planet has already changed the search for life forever. Because, for the first time, we are no longer asking whether living worlds might exist beyond Earth. We're beginning to identify specific places where they just might. And somewhere beneath the clouds of K2-18b, orbiting a faint red star in the darkness of space, a story may be unfolding at this very moment. A story that has been hidden for billions of years. A story that humanity is now only beginning to read. And perhaps, one day, it will reveal that the universe was never empty at all.